In this video, we're going to talk about how to simplify radical expressions using the multiplication property of radicals. So before we get started, let's talk about really quickly what the multiplication property of radicals is. So here we see that the nth root, and that's just a fancy way of saying any root. So that could be a square root, or a cube root, or a fourth root, or a fifth root. Any root of a product. Now remember, a product is just the multiplication of two things, and we call those things factors. So if we have the nth root of a product, in this case a times b, that is the same thing as the nth root of the first factor, a, times the nth root of the second factor, b. And what this means is that if we have an expression like this, the square root of 4 times 5, we can rewrite that as the square root of 4 times the square root of 5. And this is going to be really useful to us as we go about simplifying these radical expressions. Now, don't try to do this with any other operation except multiplication. In other words, the square root of 4 plus 5 is not the same thing as the square root of 4 plus the square root of 5. This property of radicals only works if we're multiplying underneath the radical symbol. The same thing were to apply if we were to look at something like the square root of 4 minus 2. The square root of 4 minus 2 is not the same thing as the square root of 4 minus the square root of 2. This only works when we're multiplying underneath the radical symbol. All right, so let's use the multiplication property of radicals to help us simplify these expressions. Remember, for a radical expression to be fully simplified, the radicand can't be divisible by any perfect squares greater than 1. The radicand cannot contain a fraction. It cannot have any negative values. And we can't have radicals in the denominator of a fraction. All right, so let's look at the square root of 12. Because we're trying to simplify square root here, we know that the radicand, this number, cannot be divisible by any perfect square greater than 1. So let's write down the first few perfect squares. All right, so here's a list of the first few perfect squares. 1, 4, 9, 16, and 25. Is 12 divisible by any of those perfect squares? If so, what's the biggest perfect square that evenly divides 12? Well, that's easy to see because 12 is a relatively small number. 12 is divisible by the perfect square, 4. But it can't be. The number underneath that radical symbol can't be divisible by a perfect square bigger than 1. So how do we fix that? Let's start by rewriting 12 as a product of that perfect square, 4, and another number. So what times 4 gives us 12? Of course, it's 4 times 3. So the square root of 12 is equal to the square root of 4 times 3. But now using the multiplication property of radicals, we can rewrite that expression. The multiplication property of radicals says that we can rewrite the square root of 4 times 3 as the square root of 4 times the square root of 3. Now we can simplify each of these square roots if we're able. The square root of 4 is 2, and that would still be multiplied by the square root of 3. Now we have to ask ourselves this question. Is the expression 2 times the square root of 3, or 2 square roots of 3, is that expression fully simplified? Well, the number underneath the radical symbol can't be divisible by any perfect square bigger than 1. Is 3 evenly divisible by any perfect square other than 1? No. So the first requirement of being fully simplified has been met. The second requirement is that the radicand cannot be a fraction. Well, 3 is not a fraction, obviously. So the second requirement has been met. The third requirement is that the radicand can't be negative. Well, obviously 3 is not a negative value, so that requirement is met. And then last, we can't have any radicals in the denominator of a fraction. Well, this isn't a fraction expression, so that requirement is met as well. So that means that this is the fully simplified form of the square root of 12. So 2 square roots of 3 is the fully simplified form of the square root of 12. Let's look at the one over on the right. 3 times the square root of 98. Again, because we're trying to simplify a square root, the number underneath that square root symbol cannot be divisible by any perfect square greater than 1. So let's look at the list of perfect squares that we made over here on the left. Is 98 divisible by 4? And if you need to use your calculator to figure that out, then fine, use your calculator. If we divide 98 by 4, we get 24.5. So 98 is not evenly divisible by 4. All right, what about 9? Is 98 evenly divisible by 9? No. What about 16? Will 16 evenly divide 98? Nope. What about 25? Nope. But just because we stopped our perfect square list with 25 doesn't mean that there's not a bigger perfect square that will evenly divide 98. As a matter of fact, we need to keep listing perfect squares until our list contains values that are greater than half of the number underneath the radical sign. So let's list out some more perfect squares so we can keep checking to see if there are any perfect squares that will evenly divide 98. The next perfect squares are 6 times 6, which is 36, 7 times 7, which is 49, 8 times 8, which is 64, and I can stop my list there because 64 is well more than half of 98. So let's go back to 36. Will 36 evenly divide 98? No. Will 49 evenly divide 98? Yes. 49 is a perfect square that will evenly divide 98 2 times. So we can say that 3 times the square root of 98 is equal to 3 times the square root of 49 times 2, because 49 times 2 is 98. But the multiplication property of radicals says that we can rewrite the square root of 49 times 2 as the square root of 49 times the square root of 2. And now we're able to simplify the square root of 49 because 49 is a perfect square. The square root of 49 is 7. So we have 3 times 7 times the square root of 2. Let's simplify a little bit further because 3 times 7 is 21. But we still have a square root in this expression, so let's check it to see if that square root is fully simplified. Does the square root of 2 meet condition number 1? In other words, is 2 evenly divisible by any of the perfect squares in our list? No, the only one it's divisible by is 1, and 1 doesn't matter. So condition number 1 has been met. Is 2 a fraction? Of course not. So condition number 2 is met. Is 2 a negative value? Nope. Condition number 3 is met. Is there a radical in the denominator of a fraction? Nope. This is not a fraction, so there are no radicals in the denominator. So that means that the square root of 2 is a fully simplified radical expression. So that means that the fully simplified form of 3 times the square root of 98 is 21 times the square root of 2.